Hello and welcome to all students. This is FY class semester 2nd, paper 1st, calculus 2nd, unit number 2, differentiability of functions. Today in this lecture we are going to discuss about left hand and right hand derivative of function. So this concept is similar to the left hand limit and right hand limit of a function. So the today's concept is left hand and right hand derivative of a function. So let us write the definition of the left hand and right hand derivative of a function. Okay, so let us write the definition. Let us write the definition. If f is a function from interval I to the set of real number R, where I is open interval, where I denote open interval, and obviously f is a function. Okay, open interval, comma, p is a point in I, p belongs to I, be any point, then so first we define what is meant by left hand derivative, then the value of limit or limit extends to p f of x minus f of p whole divided by x minus p is called the left hand derivative of f. Left hand derivative of f, and it is denoted by derivative of f at p minus, it is equal to limit extends to p minus f of x minus f of p divided by x minus p. Okay, so this is the definition of left hand limit or left hand derivative of a function. So see the notation and definition. Okay, so in this case if x approaches towards p on from the left hand side of p, okay, x tends to p from the left hand side of p. Similarly we define the right hand derivative of a function. Second, the limit extends to p. So in this case x is less than p, that is important. Extends to p, but in this case x is greater than p. Okay, and limit extends to p, limit of f of x minus f of p whole divided by x minus p is called the right hand derivative of f and it is denoted by, and it is denoted by this notation: derivative of f p plus is equal to limit x tends to p plus f of x minus f of p and whole divided by x minus p. Okay, so this is the definition of right hand derivative of a function at point p, and in this case x approaches towards p from the right hand side of p. Okay, let us we write the one remark. Note that as in the case of derivative of f, which may or may not exist, the left hand derivative or the right hand derivative of function also may not exist. In fact, in continuation of the definition, we have the following result. Let us write one result. That result is important. So result says that if f is a function from interval I to the set of real number r, and I is the open interval, and f is said to be differentiable if and only if f is differentiable if and only if it satisfies the following three conditions. Means derivative of f differentiable at p belongs to I if and only if derivative of f p minus exist. Okay, then second, derivative of f p plus exist, and third is derivative of f p minus is same as derivative of f p plus. Means left hand derivative and right hand derivative, they must be equal. This value is the derivative of f at p, and the same value is nothing but the derivative of function f at point p. Okay, so let us try to solve some examples based on these left hand derivative and right hand derivative. Okay, so let us write here some examples. Okay, so let us write first question. Okay, first question is okay, check the differentiability of a function at x is equal to 0. So we write here check the differentiability at x is equal to 0 for following function, and that function is f of x is equal to 0 when x is less than or equal to 0, and f of x is equal to x square when x is strictly greater than 0. Okay, so this function is given to you and we have to check the differentiability of this function at x is equal to 0. So let us write the answer for this question. Answer. So we find the left hand derivative, right hand derivative of that function at point x is equal to 0. So let us start. First we find left hand derivative. Left hand derivative means d minus of f at 0, and by definition it is left hand derivative. Here the notation is different. The notation is like this: derivative of f 0 minus, this is the notation for left hand derivative, and x tends to 0 minus. Okay, in this case x approaches to 0 from the left hand side of 0, and f of x minus f of 0 and whole divided by x minus 0. Okay, so this is left hand derivative of function of given function. Okay, so let us put the values now. It is equal to limit, obviously now we are considering x approaching towards 0 from the left hand side. So f of x, the value of f of x when x is less than 0 is 0, minus f of 0 is again 0, whole divided by x minus 0, so whole limit will be 0. So derivative of f 0 minus is 0. So this is the left hand derivative of function f. Now we find the right hand derivative. Second, we find right hand derivative. Okay, and the right hand derivative is denoted by the notation derivative of function f 0 plus, it is equal to limit x tends to 0 plus, so in this case x is greater than 0, and f of x minus f of 0 whole divided by x minus 0, and it is equal to limit x tends to 0. In this case is x is greater than 0, so when x is greater than 0, f of x is x square, and f of 0 is 0, x minus 0, and okay, so just simplify this limit. It is equal to limit x tends to 0, it is only x. Okay, and it is equal to, when we put it, it becomes 0, so limit of x as x into 0 is 0. Okay, so this is the value of right hand derivative of function f. Okay, now we observe that here, so derivative of f at 0 minus is same as derivative of f at 0 plus, and the same value is equal to 0. Therefore we can say that the derivative of function f at x equal to 0 is 0. Okay, so this is our final answer, and this shows that function is differentiable at x is equal to 0. Okay, so let us take next question. Question number 2. Let us take next question. Question number 2. Check differentiability of function at x is equal to 1. Check differentiability of function f at x is equal to 1. Here function is given f of x is equal to 3x minus 9 when x is less than or equal to 1, and x square plus 2 when x is greater than 1. So this is given function. Let us write the answer for this question. So in first case we will find the derivative of function f at 1 plus. So this is right hand derivative. We find 1 minus first. Okay, 1 minus means left hand derivative. Okay, left hand derivative. So what is formula for derivative of function f? 1 minus, and this is left hand derivative of function f at x is equal to 1. X tends to 1 minus, and f of x minus f of 1 whole divided by x minus 1. Okay, and in the next line, limit x tends to 1, in this case x approaching towards 1 from the left hand side of 1. So in this case, what is the function when x is less than 1? That function is 3x minus 9. Okay, minus, and what is f of 1? F of 1 is also 3x minus 9 and whole divided by x minus 1. So value is again 0 in first case. In first case the value will not be 0. So see here, f of 1 will be this thing. 1 minute. Okay, so f of 1, value of f of 1 is 3 into 1 minus 9. Okay, divided by x minus 1. So it is limit x tends to 1 whole divided by, this is 3x minus 9 and this is minus 6, so plus 6 divided by x minus 1. Okay, it is equal to limit x tends to 1, and here it is 3x minus 3 divided by x minus 1. Again we take a common, limit x tends to 1, 3 is common, and what is left is x minus 1 divided by x minus 1 get cancelled, and the limit is 3, and this is the value of derivative of f at 1 minus. Okay, so this is the value of left hand derivative of function 3. Now we find the derivative of f 1 plus means right hand derivative. So derivative of function f 1 plus is equal to limit x tends to 1 plus f of x minus f of 1 whole divided by x minus 1, and it is equal to limit x tends to 1, but in this case x is greater than 1. Okay, means x approaches towards 1 from the right hand side of 1. Okay, so from the right hand side of 1, so in this case when x is greater than 1, the function has value, function is x square plus 2 minus f of 1 is again 3 into 1 minus 9 whole divided by x minus 1. Okay, it is equal to limit x tends to 1, here it is x square plus 2 minus plus 6 whole divided by x minus 1. Okay, now put x equal to 1 and we get it is 1 plus 2 plus 6 divided by, don't put 1 here. Okay, we must have to remove the factor x minus 1 from the numerator. 1 minute, here it is plus 6 8. Okay, so this limit does not exist. Does not exist, so therefore derivative of f1 plus does not exist, therefore f is not differentiable, not differentiable. Okay, so function f is not differentiable because its right hand derivative does not exist. Now this is the end of this lecture, and thank you for paying attention. Thank you very much.